how can I convert this release, the rate of release, to a kind of, say, if I have cubic meter of air, how long it takes to dilute this to kind of reasonable sort.
Anything dilutes according to the volume, right?
Right. So that's,
you can have one little drop of, let's say, very dangerous poison, and if you put in a glass of water and drink it, well, you drink all of them.
because this unit has no area, no volume. So how can I do it? The dilution. How can I calculate the dilution?
No, this is not because of dilution. It is the amount coming. It's like opening the tap.
Yeah, it's like
from
a
the
flux.
water.
I know it's like a flux.
Yeah, it's a flux.
Yes, I know it's a flux, but say giving a, how to say, say the boundary layer of the air is about 1 kilometer, say.
Yes.
And within 1 kilometer radius, how long it takes for this kind of flux?
That's what I'm going to tell you. So be patient. Okay. Yes.
Can we please wait for questions until he's done? Thank you.
Okay.
Okay. Now, our laboratory have the means to measure the radiation. We are continuously monitoring. So that if you open this, you have the printout there. If you open this page, you can tell the radiation level in Tsukuba at this moment. We have no intention to conceal. It is the honest value we see on our monitor. Now, I have to sort of qualify this, that since we are not getting enough power, only the small number of stations are allowed to operate. If we have many stations, we can average it. We do not have the computer connection from the monitor, and you have to go there using some like a USB type things and read it out and bring it over analyze. We are not even getting that much power to operate. But the numbers are correct. We are not making up anything, we just tell you the number we see. Right? Now, here, this is 0.002 millisievert, which is fairly small than this, right?
No.
Yes?
This is incomparable values.
Hmm?
This is incomparable values. So, in the first you present the rate. So in the second one you present power.
Right.
So it should be.
Oh, I'm sorry, this is my mistake. Power. Look, I've been doing under darkness. But my apologies, yes, you're right. You are right, absolutely right, that's my mistake. Okay. Now, in this scuba area, inside our site, which is about 0.0007 to 9, so that what we see from the natural background, without any accident, is twice as much than normal. So we see it, but amount is so low, you don't care very much about, right? I will show you the graph later on. Next page, please. Here is the other monitor, we see it. Now this is March 15th. And suddenly we start seeing, this is negligible level, therefore we don't even give a damn. And then suddenly there's a peak, and then another peak, which is 9 o'clock on the 15th of March. Now we can roughly tell, according to your question, we can roughly tell tell the speed, because we have some information from Tokai village where some other laboratory, our colleagues are working. So when you see similar two peaks at different time, you can tell the speed of transmission, right? And on the 15th, the speed of transmission is roughly about 30 kilometers an hour. Now remember, from the reactor who has the accident, who have a trouble, is 170 kilometers away, right? So it takes about 6 hours for something to reach from there to here. But that's very incorrect statement. The reason is direction of the wind. In fact, from some other measurement I have seen, suppose this is Ibaraki Prefecture, and suppose this is a reactor. Here's the ocean. Tsukuba is right here, suppose. Looks like that amount of radiation sort of went around and maybe goes through this. And you don't go directly. It's not a diffusing. Alright, diffusing is very much smaller, slower. Wind carries. So it depends on the direction of the wind, the speed of the wind. So today is totally different from yesterday. The wind is mostly towards north, so that it's going the other direction. So don't remember this number, which I said 30 kilometers an hour, because it's only applicable to particular day on the March 15th under particular condition, and it's not direct movement. It's sort of wind goes this way and that way, sort of, you know, waving around and reach to Tsukuba, and you see this peak. Next one, please. Now, it was shown up to here, but now we have 9 o'clock this morning. So what do you see? The gas was emitted, and then it came down. You could explain to many ways. A possibility is that the wind was totally different direction, therefore nothing is coming here, but the same amount is in existence or emitted. Or, in fact, a big sort of emitting action was one shot, and therefore rest of them are coming down. Next one, please. Now, on that web page, what you see is this. This is about 2 hours ago. This is March 17th. This is noon, and we are right here. Now, this one is microsievert per hour. Unit is correct now, finally. And because I'm not typing it. Now, yes, there was a peak, which is yesterday around 9 o'clock. So we are a bit concerned. Still, 0.6 microsievert, which is 0.0006 millisievert. Right? And we are back to about twice as much as what we see every day. Normally, in your room, in my room, in our lab, Higashi Odori, or anywhere. Alright, next one please. Now, symptoms of acute radiation, which is what do you see in a short time when you are exposed to radiation? Now, 0 to 250 millisievert. Well, you don't see anything in a day.
That's in a day or in an hour?
It is accumulation.
Accumulation. Okay.
It is accumulation. Either you are staying at 200 millisievert per hour place for an hour, or 25 millisievert for 10 hours, or anything, the total accumulation.
I will send you all those there.
is this, and then 200 to 1,000 millisievert. This is from the Medical Institute from US, which probably does the real measurement. Again, since I'm not a specialist, but I think they are very credible, reliable. And even at 1,000 millisievert, well, lots of appetite. I wish I have one. And of course, it's not a welcome number. So that I would think if you stay within under, let's say, 200 millisievert, well, it probably is as dangerous as eating a hamburger from somewhere.